Good day, everyone. My topic is about an eight-year breeding program for Asian sea bass, latest calcariper, genetic evaluation, experience, and challenges. The introduction. Aquaculture of Asian sea bass, also known as barramundi, has seen a 350% increase in regional production from 20,000 tons in 1998 to 90,000 tons in 2017. This species is highly fecund urealine and has a rapid growth rate in both fresh and salt water. However, mass spawning which involves keeping birdfish in the same tank with a mating ratio of one female to one or two males is known to be difficult and has led to a loss in genetic diversity in many cultured stocks. Selective breeding is powerful to increase commercial production, and its success depends on a systematic approach involving several steps from establishing a base population to developing breeding objects and selection strategies. Quantitative genetics and selective breeding are in early stages of development, but substantial productivity improvement has already been achieved in fish and shellfish. These principal breeding goals for aquaculture species are growth rate, disease resistance, and product quality. In 2010, approximately 8.2% of global aquaculture production was based on genetically improvement stock, such as Atlantic salmon. Therefore, there is a strong need to develop an improved genetic line of for Asian sea bass to meet the growing demand for high quality seeds and breeding stock in aquaculture. And the next is the ethical statement. All the methods and experiment protocols of this study were performed in accordance with guidelines and regulation approved by the Animal Ethics Committee of the University of the Sunshine Coast, Australia. Approach number is ANE 1613. The experimental location. The breeding program for Asian sea bass, including breeding, rearing, and growth experiment was conducted of the National Mariculture Researching and Development Center (MRDC) and Center for Environment and Disease Monitoring in Aquaculture, associated with the Research Institute for Aquaculture Number 3 RIA3 in Can Hoa, Central Vietnam, latitude 12.25, longitude 109.19, and it's situated in elevation 2 meters above sea level. And the next is the base population. In 2011, a partial Jalil cross was carried out involving fish from four population, Bong Tao and Canoa, hatchery and wild fish from Kengiang, and wild fish from Bang Tao and Kanwa. 30 families were produced after 15 to 20 days. Parental fish were injected using LHRHA and keep in tanks from natural spawning. Fish larvae, fish larvae were nursed until fingerling size was reached. A random sample of 30 fish per family was tagged using passive integrated transporter or PIT. Fingerlings were conditioned in tanks for another weeks before being transferred into sea cage for 17 months. So the next is the maturity. Maturity of the female was determined by biopsy as described above. Section family production in subsequent generation in 2014, 2015, and 17. The maturity of males was determined by stripping method. They were recorded in the form of presence and absence, coded as 1 and 0 respectively. The deformity. Morphological deformity include a range of measures, namely lower jaw, nasal erosion, abnormal skeleton, and deformed operculum. The food conversion ratio or FCR. Total amount of feed provided in each net cage consumed by the fish was recorded to calculate FCR. This trait was not included in analysis because it was not possible to collect the amount of unitin we feed in sea cage. So the next is the heritability for survival. The study fund allow heritability estimate for survival during the grow out. The grow out phase from 105 days post hatch to 570 days post hatch, which expected for binary characters. Survival and fitness related traits are influenced by environmental factors like nutrition, feeding regimes, stocking density, and social competition. Despite these low heritabilities, the study demonstrated that there are heritable genetic components determining survival during growth. The heritability for growth traits. This study investigation the additive genetic variability for growth trajectory in Asian sea bass at 6 different time points, 105 to 570 dph. The results show moderate to high heritabilities for body weight and length across six growth stage, indicating substantial genetic variation in growth-related traits. This suggests that selection for growth should be, be affected in this population. Previous research reported heritability for juvenile fish at 90 dph, but this estimated had high standard errors and may have been overestimated due to non-accounted to for pulsive, pulsive effect. The study's significant heritability values suggest that selection to improve body trait should be effective in population. The body weight and length measured 6 times during the grow out phase from 105 to 570 days post hatch are given in table number 1. The weight and length of the fish increased steadily until 270 dph, after which there was a rapid increase in growth rate until the final harvest. At 570 days, the mean body weight was 2.3 kg and mean length was 53.9 centimeter. The, the coefficient of variation for body traits were greater in their earlier 105, 180, and 270 dph than later phase of growth development 360, 450, and 570 dph. The growth curve of the experimental fish at 6 different grow out period pedigree structure of the data is shown in table number 2. Survival traits during growth at phase 105 to 360 days. 60 days range from 30 to 100% among 30 families produced in 2013 and 40 families in 2015. And the next slide is phenotypic and genetic correlation of body weight between different times points are presented in table number 4. In general, genetic correlation of weight rates estimated for measurement were all positive 0.31 to 0.61 and significantly differed from 1. The genetic correlation between weight and length at the same age was high 0.95 to 0.99, except for the moderate estimate between W2 and L2 equals 0.38. However, the RG values between weight and length at different age were low of moderate, of which two estimates between W1 and L4 or between W4 and L2 were not different from zero due to their high standard error. Overall, the genetic correlation of traits between successive rearing period were stronger than those that are further apart. The phenotypic correlation were all positive significant. And the table number 5 show the between environment genetic correlation for weight trait. Due to the limited data record at 450 and 570 dph in both cage and tanks, the between environment genetic correlation were estimated for body weight and tree age. Body weight at tree age 180, W2 207 with 270, W3 and 360 dph. The genetic correlation between tanks and cage culture was high, 0.91 to 0.94 for W2 and W3. The genetic correlation estimate 0.84 to 0.12 was similar for total length. However, the between environment and the last is the correlation at different measurement. The study found that genetic correlation of body weight between different time points in a population of barramundi fish were positive, but the estimate differed significantly from one suggesting that body traits at different growth phase in this population are genetically different. This suggests that selection in the early stage of growth development may not capture all genetics expression at later stage or at the time commercial harvest. This contrasts with results reported in other aquaculture species such as common carp and giant freshwater prawn. The genetic correlation between weight and length measured at the same time or age were high, suggesting that these traits are under control by a similar or same set gene. The study focuses on the challenges of implementing a breeding program for Asian sea bass, including synchronized spawning and identifying G with the interaction effects for growth rates. The fish generally reach maturity after 2 years, but the sex ratio is uneven, with a larger proportion of males than female. Female are not ready to spawn, and breeding failure rates are high. Naturally, spawning rates were only 66% in the base population, while artificial insemination increased success to 78%. Selection had to be made using lower EVV, EVV candidates affecting genetic parameter and progress achieved.